We've looked at applications already. So yesterday was a day of review of something we did at the very beginning of the course. So hopefully that went okay. If you weren't here, you have seen it before. We're going to be doing more of it today, but in terms of applications, and it was solving exponential equations. You should be looking at the side of the handout that has the 1 plus r at the top. Okay. Both handouts both front and back look almost identical. Hopefully I hole punched it correctly, but you want the 1 plus r. Monday, we're doing decay. This is how I know it's growth. Because you're adding on every time, so it's getting bigger. If you're subtracting, it's decay, it's getting smaller. And part of this is figuring out which one it is. Is it growing or is it decaying? It should be obvious, but it's something you have to look at, and it is something that people make mistakes on. Like in that learning goal, some people did add when you were supposed to be subtracting. Okay, so more applications. We've already done applications, but those ones you were given, like the learning goal we just did, after 5 years or after 10 days or 10 years or whatever it is, or 10 minutes or 10 seconds, right? It gives you the time. So what we're doing today is you're solving for time. And to do that, it's an exponential equation because t is your unknown. We're going to start the way we were starting applications before by creating the model. So let's read the question first. For a science experiment, the number of bacteria start at 200. The bacteria double every 30 minutes. We talked about questions like this, but they weren't in the practice. So that's something we have to be careful of as well. How long will it take for the number of bacteria to reach 204,800? So first we're going to write out the information that we're given. The number of bacteria start at 200. So we need to know that A naught is how much you start with. If you put the two numbers in the wrong place, you're going to get a very wrong answer. If you're paying attention and thinking about it, you should be able to pick up on that and notice that. The final number of bacteria, again, is given. Previously, that was not given. You were calculating that. But it's given. It's 204,800, so that goes in here. I'm going to skip R for now. It says, how long will it take? So that's solving for T. Same thing when it comes up on the test, you'll have to be able to understand what the question is asking you to solve for. Is it giving you time and asking you to solve for the final amount? Or is it giving you the final amount and asking you to solve for time? Okay. And then N, it says the bacteria double every 30 minutes, so that's your N. And doubling, so when I write out my equation, and I'm going to write it out with A first, kind of like we were doing before, to the T over 30. That's where the N goes. What do I put in the brackets? It's 1 plus R or 1 minus R, but there's a couple of cases where we don't necessarily use that.
Well, would it be 1 plus 1?
1 plus 1, so 2, because it's doubling. So I just think of it as a 2. I just put a 2 in there, but that's exactly right. It's 1. The rate is 1, 100% growth. It's 1, so it's 1 plus 1, which is 2. Okay, and then I get 204,800 equals 200 times 2 to the T over 30. So don't write this down because I'm going to make a mistake on purpose. And I want somebody to tell me why what I'm doing is wrong. But pay attention because a lot of people, even though we're going to talk about this and we're going to practice doing it the right way, for some reason, people will forget. And on the test, you'll do it the wrong way. If you do the practice, all your answers would be wrong, so you'd be able to catch this mistake. But for some reason, every year it's a problem. People do this. This is wrong. It might look like it's right. You might say, oh, that's what I was going to do. Or you might have already done it. I don't know if you were trying to solve it. Fair enough. Does anybody know why this is wrong? Sarah?
Because the exponent is connected to the 2, so you have to do that first.
This is very well said. This is a BEDMAS mistake. BEDMAS says we do exponents before we multiply, but I just multiplied before doing the exponent. This exponent is not on the 200. When I multiply it in, now it is. That's a major problem. But if I can't do that, what do I do? Does anybody know? Have an idea? Zach, what do you think?
You bring the 204,000 over and then bring it to the other side. Okay.
Yeah, well, the easiest way actually is by bringing the 200 over to the other side and leaving the 2 where it is. Very good. That's right. So we're going to do this. And we're going to do it by dividing. Because it's 200 times this, I do the opposite, which is dividing by 200. Okay? And folks, listen carefully. When you're solving for time, that's your first step every single time. Every one of these examples will be set up in almost exactly the same way. And it'll have a number out front here. And you divide by that number every single time. So if you are paying attention and you get that and you practice a little bit, it shouldn't be a problem. But every year somebody makes this mistake. Okay, with your calculator, because I doubt you can do that in your head. I sure can't. Divided by 200 gives me 1024. And now this looks a lot like a question from yesterday. So what do we do? Sarah? Very good. A power of 2. I got to turn this 2 to something equals 2 to the t over 30. And what's our strategy for this? Guess and check. What do you want me to start at? Ben, name a number. What could I start at? 2 to some exponent that's going to give me like 1,000. 10. What are you, a plant? That was the right answer. Good guess. I like it. 2 to the 10 gives you 1024. These can be very hard to guess. I wouldn't have been surprised if somebody said 5, which wouldn't even be close. I mean, it's halfway there, but it'd be 32, so it wouldn't be very close. 2 to the 5 is 32. Or if somebody said, I don't know, 100. So let's try 2 to the 100. It gives me scientific notation because the number is so big, it goes way off my calculator. 1.27 times 10 to the 30. So a 10 with 30 zeros. So 2 to the 100 is way too big. Remember we talked about exponential growth. It gets big fast. Anyway, so 2 to the 10 was correct, but you might try a few things before you get there, but as long as you get there, and remember the way that we write it is important. You don't write 2 to the 10 equals 1024. We write it like this, and then we say, therefore, 10 equals t over 30. And what do I do for my last step here? Because I'm solving for t. Pearson, what do you think we do?
Divide 30 out of the t.
Yeah, but I'm not going to divide. I'm going to get it out of there. But what am I going to do to move it? Very good, multiply. So multiply both sides by 30. Okay, and I get 300 equals t, or t equals 300. Word problem, interpret your answer. T is 300. What does that mean? We go up and we reread the question. T stood for how long? It was in minutes. Remember, t and n always have to be in the same units. So that means it took 300 minutes for the bacteria to grow from 200 to 200,000. All right, we'll do one more example together. There is something a little bit different about this one. How long would it take for a population of people to grow from 500 to 1,047, assuming the growth rate is 3% per year? I don't know about you, but when I read these questions, I realize how useful this skill is. This is something that I can imagine people who work for companies or organizations, like maybe nonprofit organizations or that work for a city or something like that, that they would be doing this kind of stuff. Our population of people right now is 500, but like our infrastructure can only support up to 1,000 people. At this growth rate, when will that happen? How long until we have to expand the infrastructure, meaning bring more water in or more electricity, like a better power grid or better internet or something like that, right? Like these are real problems for real people, everyday people who are putting in new houses, building new houses, towns that are getting new development, cities that are getting new high-rise buildings. Like this is stuff people actually have to think about. I can personally see how this is like a useful real life skill for somebody out there. All right, so let's give it a shot. You can go ahead and get things started if you want, at least start trying to put some values in. So when I look through this, I see it's starting at 500. That's where it's starting from. And it's going up to 1,047. That means it's growing. So I'm going to be adding the rate. The rate is 3% per year. How do we do that? We do 3 divided by 100, 0.03. T is what we're looking for. It says how long would it take, so I know I'm solving for time. And N is, it's 3% per 1 year. So N is 1. Remember we talked about this last time. When N is something other than 1, like in the last example, it was doubling every 30 minutes. I think once you get this, it's obvious. Oh, that's the N, every 30 minutes. When it's not there, sometimes it's harder. And you might think like, what's N? Because it doesn't really tell me what N is. And usually that means it's 1, if you're not entirely sure. But if it says per 1 year, that means N is 1. So A equals 500, 1 plus 0.03 to the T over 1, so just T. And then if I sub in 1,047 equals 500 times 1.03 to the T. So what's my first step? What did we talk about for the last one?
Divide both sides by 500.
Right. Divide both sides by 500. To get rid of the 500 on the right. And 1,047 divided by 500, I'm going to write down all the decimal places, 2.094. I am not going to round that, but that's all the decimal places. Equals 1.03 to the T. Next step is I got to get 1.03 to some exponent equals 1.03 to the T. That has to be our next step. And this is the case, we did talk about this yesterday. This is the case where it's certainly not obvious. Like the last one worked perfectly. 2 to the 10 is exactly 1,024, right? But this one with decimals, you kind of think, oh, I don't know, is this actually going to work? Well, it's going to be close, but it's not going to be perfect. Somebody name a number for us to try.
15.
Good guess. 1.03. It's not quite right, but it's a good ballpark. Because, like, again, these ones is hard to estimate. Where would you even start? So, I don't know. Try 5. Try 10. Try 15. So 1.03 to the 15 is 1.5579, or 80 actually, rounding properly. So I'm going to keep 4 decimal places for now, and that's not really 2.04. It's smaller, so I got to go bigger. So I got to try something bigger. So 1.03 to the 20, and I'm just writing these down right now for sort of the note, so that you can see my train of thought. 1.8061. So I'm getting closer. Okay. 1.03 to the 24. .0328. That's a lot closer to 2.09. We may be able to get closer, we may not. So we're just going to keep trying. So I'm going to try 25. And I'm going to try 26. That got closer, so I'm going to try 26 again. I'm going to keep going though. Like that looks really close, 2.094. This is 2.0938, which is 2.094. That's really close, but we're going to try one more anyway. There's a reason for that. 2.1566. So the rule here is, and this is just for a matter of showing your work, I want you to, you have to show at least 3, and I want to see you write them down. The one that's correct, the one just before it, and the one just after it. You may do other ones on your calculator. I want you to write down those 3. Even if you guess correctly on the first one. The reason why is because I want to see that this one's too small and this one's too big, so that's the one we're going with. And we could get even closer if we started doing decimals, 24.9, 25.1, but we're not doing that. You don't have to do that. So I want to see 3, and then we're picking 25. It's very close. In fact, if you round, it gives you 2.094. Therefore, 25 equals t, or t equals 25. Therefore, what was this question talking about? It'll take, therefore, it will take 25 years for the population to grow that big.